This video is going to cover Unit 18-3, complete quadratic equations. So far we've seen something in the form of a times x squared is equal to c. Now we're going to see complete quadratic equations where all the terms are filled out. So it'll be, like we saw before, the ax squared plus bx plus c equals 0. Now, there are three main ways that we can solve these types of problems. I'm looking at page 500 right in the middle. Factoring. So you could factor these things out. You may have had an algebra class before where you factored them. We're not going to be factoring them. The other way is completing the square. Now, completing the square is a more complicated way of doing it. And to be honest, completing the square is mainly used to convert what we would call a quadratic in standard form, which is what this is, to something that's in vertex form, which is something that we're not going to be dealing with. You can also solve them using completing the square. The way we are going to solve them, which I think is the easiest way to do it and the best way to do it, is using the quadratic formula. Now at first it might seem a bit daunting, but it's not really that bad. The quadratic formula states that x equals negative b plus and minus, that's that plus and minus where we get our two answers from, the square root of b squared minus 4 times a times c, all of that divided by 2a. Okay, where do we get all of these from? They're right here. A, b, and c. A is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is the constant. And you put them in. The 4 is a number that's always there, okay? This is the quadratic formula. Solves quadratic equations. And this is where we get our two answers from. Now, this part right here, what's underneath the radical is what I call the determinant. The determinant. Some people call it I've seen it in textbooks as the discriminant. This is the part of the equation that determines what your answers are going to look like. If this underneath this radical is a positive number, you will have two answers. So if I draw my xy, so you will have a parabola either opening up or down that crosses that x line 2 times. And once, like we mentioned before, these would be your two answers. If underneath this radical it comes to 0, then you will have a parabola that looks something like this. It either opens up or down, and it comes into contact with the x-axis 1 time, and that's it. The vertex touches the x-axis. You still have two answers, but the two answers are the same. So technically there's one unique answer. Okay? Now, if underneath this radical you get a negative number. Now remember, we've already talked about this. You cannot take the square root of a negative number. Or can you? You can take the square root of a negative number, but we get into what's called complex numbers. Or imaginary numbers, and we will not be dealing with those in this class. The parabola, if this is a negative number, the parabola would look something like this right here. It would never come into contact with the x-axis, so it does not have any zeros or any roots. We have to imagine where it might make contact or something like that. But this is the determinant. This is the part that I do first, and I check that. Now, if you're doing a problem and you do this part first and it comes out to be a negative number and you're absolutely certain you did it correctly, I don't think they're going to do any of those to you in this book. But if it did and you're absolutely certain you did it correctly, then that is where I would stop. And I would say no real answers. I wouldn't even mess around with the rest of this stuff. This is the part that I do first, because I want to see what my answer is going to look like. Do I have one unique answer? Do I have two individual answers? Or am I looking at something in the imaginary world? Okay, so let's take a look at an example on page 501 where we have 5x squared minus 3x minus 2 equals 0. Okay, so A is equal to 5. B is equal to a negative 3. And C is equal to a negative 2. So let's put them in. Now, you have to be very careful with the negatives. You always have to be careful with your negatives, because here in the quadratic formula, that's a negative b. All right? Now, in our case, b is a negative number. So this negative goes with the quadratic formula, and that negative goes with that 3. So the negative for the quadratic formula goes first, and then the negative that goes with the 3 goes second. Then plus and minus, and the square root of b squared. Now I never write the negative number underneath the radical because you're squaring it. Any number squared is going to be positive. So it doesn't matter whether it's a negative or a positive. So I would say 3 squared minus 4 times a, which is 5, times c, which is a negative 2. All of that divided by 2a. Now, simplifying this, we have this becomes a positive right there. That's 10. Let's look under here. Negative and negative is going to make a positive. So 4 times 5 is 20. Times 2 is 40. And this is going to be a 9. So 9 plus 40 is 49. So underneath that radical is 49. So it's going to be 3 plus and minus the square root of 49 divided by 10. Square root of 49 is 7. So this is going to be 3 plus 7 divided by 10. That's one answer. And 3 minus 7 divided by 10, that's the other answer. So this is 10 over 10, which is 1, and this is a negative 4 over 10, which simplifies to be a negative 2/5. So my two answers are 1 and negative 2/5. Okay? So let's take a look at some more examples. Now, once you understand how to use the quadratic formula and you understand how to use the negatives, that's the biggest part. Understand how that negative works. So you've got a negative underneath the radical, minus 4, and you have the negative b. So let's take a look at let's see, I like that example right there. I'm looking at example number 3 on page 502, where we have x squared minus 10x plus 25 equals 0. So if you're given an equation and 0 is not on one side, you have to get 0 on one side. My battery is dying, so I'll be right back.